Hey everybody, Mr. Seward here, and today we are going to create a development drawing of this truncated prism, or pyramid, excuse me, that I have right here. So we're going to use the information that's given on the drawing, and note the height of the pyramid is not equal to the length of each surface. We're going to include tabs for all the surfaces that are going to mate together. And then we are going to add your name to it prior to cutting and folding. Please remember that neatness and accuracy are going to count, and keep tabs or tape off of the outside of the pyramid. Okay, so the first thing we are going to do here is we're going to label the edges or the corners. And this is going to be corner number 1. And then number 2 is down here, number 3, and number 4. Now, just like we've done the bottom of this pyramid, in other words, these points here, we're going to do the top. So this is going to be 5, 6, 7, and this one here is 8. Now, up here, this corner right here is going to be numbers 1 and 2, points 1 and 2. This corner over here is going to be points 3 and 4. And then we're going to get let's see, this one up here is going to be at the top of the pyramid. So this is 7, 8. And this is 5, 6. So what we need to do this development is the true lengths of lines. So the bottom of this rectangle is, if the bottom of that rectangle is parallel to the XY line, then that means that 1 to 4 and 2 to 3 are true length lines. Same thing for 1 to 2 and 3 to 4. Those also are parallel because we would have the vertical line going up and down here. So it's the same also for the top lines here. These are parallel to the planes, and that means that this line from 5 to 6 and also 7 to 8, those are true length lines, and 6 to 7 and 5 to 8 are also true length lines. Now, when I look at this drawing, I'm going to look at these lines right here. These are the other lines that are on here. 1 to 5, 2 to 6, 3 to 7, and 4 to 8. And those are not parallel to any of the planes, which means that these are not true length lines. Now, because this line 1 to 5 is not parallel with my XY plane, that means that this line is not a true length line. It also is not a true length line here in this upper view. 1 to 5 is not a true length line. So we need to find true length for that line 1, 5. Now, once we find this true length here, that's going to be the same length for 2 to 6 and for 3 to 7 and for 4 to 8. All right, so now point 5 here is going to be what we call the apex of a cone. And from point 5, I'm going to draw a generator line. So I'm going to just line up my T-square there, and I'll draw this out. And I'm going to take my compass now, and I'm going to measure the distance from point 1 to point 5 with the compass. Okay. And what I'm going to do is from point 5, I'm going to swing an arc around until I get to the generator. Whoops, I put my generator in the wrong spot. Pause that. Okay, so all I did was I just erased that horizontal line that was my generator, which was incorrect. And I'm going to go up here to line 1-4, and I'm going to put my line across there. Okay, now back to my compass. Just double check my setting. Yeah, it's still good. And I'll put my compass on here, and I'll bring it up to my correct generator line. So this line right here is what's called the extreme generator. Okay, and what we're going to do is we're going to take that extreme generator, the intersection of our 0.5 arc, to right there, and I'm just going to draw a straight line up. Oops, I think I hit my camera. There we go. Okay, now what I'm going to do at the top here is I'm going to bring the top line across to that extreme generated line, and this is the new position of point number 5. So now if I use my triangle here to connect from point 1 right here up to point 5 here, that'll give me the true length of line number 1 to 5. Okay, and what I'll do here is I'll put arrows on the ends of this. This is getting a little mixed up down here, but anyways, so that is the true length of line 1 to 5, which is right down here, 1 to 5. Now I'm going to label this, and I'm going to put TL 1 to 5 here, just to keep that straight. Okay, now that we've got the true length of all of these lines, so from 1 to 2, those are true length, and 2 to 3, and 3 to 4, and 4 to 1, and then the true lengths we already know are 5 and 6, and 6 to 7, and 7 to 8, and 8 to 5. Those are all true lengths. And we've also measured and gotten the true length of 1 to 5 and 2 to 6. That's what this line is here, 3 to 7, and 4 to 8. So now we have all the true lengths that we need, and what we need to do is we need to start doing our flat development. Now, the way we go about doing that is I'm going to just come out here to this side of my paper, and I'm just going to put a point. And that point is going to be labeled as number 1. Okay. Next thing, I'm going to pick up my compass, and I'm going to measure with my compass the distance from 1 to 2. So let's see, I'll put my compass on here, and I'll bring this out to here, and I'm going to come over to my point, and I'll put my compass in there, and I'm going to swing an arc right down there. Okay, so now the only thing I've done here since I last showed you is, remember I swung the arc from 1 to 2, the length of 1 to 2 right here, and all I've done is I've taken my triangle and my T-square, and I've drawn a line straight down from point number 1, intersecting that arc, and then I've written the number 2 right down there. Okay, so now what I need to do is I'm going to use the true length of line 1 to 5, which is right here. So I'm going to get my compass set up with that true length. And I'm going to come over here to my point 1. I'll put that in there. And I will swing my arc somewhere out in here. Okay, so now I have the true length. I used my compass to swing that from 1 to here. But where on this arc is point number 5? We don't know that yet. The other thing, though, is I need to get my true length for 2 to 6. And we know that that line right there is the same length as this. So I'm just going to use my compass point or measurement from up here. This is the true length of 1 to 5, remember. I'm going to come over here to point number 2 and put this. And now I'll swing that one right there. So we don't know on this line where point 5 is, or this arc, and we also don't know on this arc where point 6 is. So we have to create one more true length line. And in order to do that, I'm going to make a line on this surface going from 2 to 5. So let's set that up. So now I've split this surface into 2 triangles. I've got the triangle 1, 5, 2 and 2, 5, 6. And I want to get the true length of this line from 2 to 5. So if we consider point 5 here, the apex of a cone, and it's up here already, the distance from 5 down to 2 is going to be the radius of the cone. So I'm going to get my compass here, and I'm going to measure that distance from 2 to 5. Now I'm going to come up here to this intersection where we have this line that we use to create point number 5. And I'm going to put my compass point on there. Oops, come on, you. There we go. And I'll swing that arc. Now, I'm going to connect from this intersection down to this intersection. And I'll put the arrows on here. And this is point number 2. So this line right here is the true length of 5-2. Now with my compass, I'm going to measure the true length of 5 to 2 right up here. So get my point right there. Bring my compass out. It goes right there. And then I'm going to come over to the development, and I'm going to put my compass point right at the intersection where point number 2 is there. And I'll swing that arc. And then I'm going to label this as point 5. Now, I'll connect the intersection to the dot here. So from 5 up to point number 1. All right. And then what I'm going to want to do is I'm going to find the intersection on this arc for point number 6. So how I do that is I use the true length of point number of line number 6, 5, or 5, 6, however you want to read that. So again, I'll get my compass here. I'll bring that in. And I'll come back to my development and place my point right there. And I'll swing that arc. And I'll label this one 6. And then I can connect 5 to 6. Right there. And then from 6 to 2, that's going to be a fold line because of our development. So a fold line is going to be a bunch of dashes in a row like this. You know, as a matter of fact, I'll get rid of some of this arc because it's getting a little confusing. Right there. So this development surface right here is the actual true shape of this surface right here. Now we got to go on to our 2673 surface. And it's the same thing again. So the first thing I'm going to do is I'm going to get the true length of line number 2 to 3. So here we go. So from 2 to 3 right here. And I'll come down with my compass and put my point in at point number 2. And I'll swing an arc. Now we don't know exactly where point number 3 is going to be along this arc. But it's going to be just like we did on the prior one. I'm going to go here and I'm going to get my true length of 6 to 7 or 7 to 6, whichever way you prefer to put that. And I'm going to come up to my point number 6 and I will swing this arc out here somewhere. Okay. All right. So that one comes from point number 6. So now we got to create another true length line. So I'm going to do just like we did up here. They call this the triangulation method because we're creating all kinds of triangles here. So I'm going to go from point 3 to point 6. That is going to be this. I've broken this into the surface again into 2 different triangles. Now I'm going to draw using my square and my triangle here. I'm going to draw a line that comes from point 6, also from point 5, up through this XY plane line. So line that up, and I'll just draw a nice construction line right up through there. Now what I'll do is with my compass, I'm going to take the measurement from this 3 to 6 line. So I'll put my compass point at 3. I'll measure out to 6 right there. And then I'm going to come up to this intersection that I just created right here. And I'm going to swing an arc. And this is the new point of 3, 6. So again, I'm going to draw the true length line on here. So I'm going to connect that intersection with the one up here. Okay. Now it just so happens, by the way, that this length right here happened to hit this intersection, but on other developments, you might actually need to extend this line out a little bit. So that you can actually create a cross out here in this area. But anyways, so this is going to be the true length of 6 to 3. And again, I'll put my arrows on here. Okay. Now, with the compass, I'm going to take a measurement here from 6 to 3, this true length line, from 6 to 3. I'm going to come up here to my 0.6 on the development, and I'll swing a line. So that becomes my point number 3. Now I'm going to use the true length of my line 1 to 5 because that's the same as it is over here, 1 to 5 right here. Excuse me. And I'll put my compass point there. And I'll move this in until I get my true length. Then I'll come down here to my point number 3, and I'll connect that one. And this is point number 7, I think. Yeah, this is point number 7. So I'll connect the crosses here. So there's a little point there, and there's a little point there. We'll do the same thing from here, from 3 to 2. And then going from 7 to 3, this is going to be another fold line. So this is going to be a series of dashes right here. So that is 2 surfaces of my development. So now we're going to use this triangulation method to complete the problem. So I'm going to use my compass to measure this distance from point number 3 to number 4. And I'll come down here with my compass point and put it in number 3. You can see it now. And I'll swing this arc. Same thing, I have the true length of 7 to 8. So I'll put my compass point on 7. And I'll measure that one out right there. And I'll come up to point number 7 on my development. And I'll draw that one in also. So we don't know where on here is going to be point number 4. And again, we don't know on here where point number 8 is going to be. So if you look close, this side over here, this surface 1562 is exactly the same as 3784, except it's been flipped over. So that means that if I take my triangle here and I draw a line from 3 to 8, that length of that line, the true length of that line, is going to be the same as this one is 525 or 52. So this true length is the same for this one and for this one right here. So I'm going to take my compass. I'm going to set this up with my point on 5, and I'll open this up to 2 right here. And I'm going to go to my point 3, and I'll swing an arc, and this is actually going to be point number 8. Okay, and then I'm going to take and look, and you can see that the length of 4 to 8 or 8 to 4 is the same as 5 to 1 or 1 to 5 over here. So that's what this is, and I'm going to establish my point number 4 over here by doing this. So I put my compass point right there, And I bring my compass in. So I go to point number 8, and I swing my arc there. Now I can connect things up. So this is going to be a object line right here, and an object line right here. And then this is point number 4 down here. So this one is going to be a fold line. Last of our fold lines. Right there. Okay, so now we got to complete the last part of the problem. So I'm going to take the true length of 4 to 1. And I'll come down here to my intersection of 4. And I'll make an arc with that. And then I'm going to take the true length of 8 to 5 here. And I'll make this one, so go from that point right there. And this will come up like this. Okay. So now to finish this out, we're going to keep in mind that this surface here, 2, 6, 7, 3, and this surface here, which is 1, 5, 8, 4, those are exactly the same, except they're flipped, so they're symmetrical. So if I drew a line from 4 here to 5, the line goes like this, from 4 to 5. And we want to use the true length of the line 4 to 5. And again, thinking about it clearly, you're going to know that this line is exactly the same as 3 to 6 or 6 to 3, whichever way you want to say it. And we have this true length right up here already. So I'm going to take my compass, and I'm going to go from 6 to 3. And that's the equivalent of going from 4 up here. Now where that crosses is back to, this is going to be back to our number 1. Oops, that's not point 1. That's actually point 5 because it's going to connect back up over here. So this is point 5. All right. So now I have to go to point number 1 over here. And how I do that is I use the true length of my 1 to 5 because it's the same. 4 to 8 is going to be the same thing. So I measure my true length of 1 to 5. And I come over to this intersection of 5 right here. And I swing that arc. And this one here is a little short, so I'll just extend this. Okay. So now this is the intersection of point number 1. So I'll put a little dot there and there. And I'm going to draw my object line in. Oops, right there. And then from 5 to 8, draw that one in. Then from 1 to 5, this is an object line also. And there you go. That is that construction of that truncated pyramid. Okay, so the very last thing I need to do here is I need to put a tab on either this end here, 1, 5 here, or 1, 5 up here. Doesn't matter which one I do. I'm just going to line my little triangle up here on this line, and I'll just draw a little tab out somewhere around, you know, a quarter or 3/8 of an inch. Doesn't really matter how long it is. All right. And I'll connect the dots there. You could probably make it a little smaller than that. But that's that tab that I'm going to use to glue this thing together on the inside when I fold it all up. Okay, so that's the end of that problem.